Hi all, Karl here. In a previous video dated September 25th, 2022, I ran a high RPM test on this 350 Chevy engine that I was running 100% hydrogen on. Now, it was the first time that I ever pushed the limit up to that threshold, but I was trying for 4,000 RPM and I fell short to 3,800 RPM because I ran out of hydrogen. So what we're going to do today is run a thermal test on the exhaust gas temperatures, or EGTs. So what I'm going to do is start up the engine on gasoline first. I'm going to get it up to temperature, and then once it gets up and running, I will check the temperatures of the exhaust gas, and you'll be able to see the control panel cluster here with the thermocouple that is connected directly into the exhaust pipe with my Omega temperature digital reader. So that'll give me a real-time view of the exhaust temperatures that's coming out of the engine at the time that it's doing it. And I will be able to compare the gasoline exhaust temperatures to the hydrogen exhaust gas temperatures once I run it on hydrogen after the gasoline test. So what we have here is the hydrogen that is controlled by the main valve. This is a flow regulator valve that flows down through the flashback arrestor. So if anything goes wrong, the flame actually cannot go back into the hydrogen tank itself, comes down through the line into the fuel regulator, and then is distributed through this fuel rail injector system that I built custom just for this engine. And then I will be able to run this up to 4,000 RPM and check the EGTs against the 4,000 RPM of gasoline. Again, we're here in the R&D lab of Element One Technologies at the San Rafael Energy Research Center. And this is the second stage of testing the EGTs, or exhaust gas temperatures, in my 350 Chevy engine that runs on gasoline and hydrogen. Right now, I have now hooked it up for hydrogen. As you see, there is gasoline in the siphon funnel. We ran the previous video to show the first stage of testing the EGTs on gasoline, and now we're going to run this up on hydrogen. I will, as always, show that the engine is consuming the gasoline through the fuel line, and then I'll turn on the hydrogen once it runs out of gas and run it on 100% hydrogen. Then I will run this up to 4,000 RPM to get a reading of the EGTs on my Omega meter that is directly connected to the thermocouple in the collector exhaust. So I'll turn the master power on, the fan, the fuel pump, and the coil power, and get this baby fired up, give it a couple of pumps of gas. Starts up really nice. Let's get it up to a little bit of operating temperature. As you will see, the gasoline will start to drain out of the funnel. Let's get this up to temperature rather quickly to save some time. So we're looking at 180 degrees Fahrenheit for the water temperature, at 50 psi on the oil pressure, and we're running just below 14 volts on the battery. Right now at idle at 1400 RPM, we are stabilized around 562, 567 degrees Fahrenheit in the EGTs. So I'll get this, once we run out of gas, I will get this up to 4,000 RPM. As you see, the gas is almost empty in the funnel. It is now drained. It's going to go down through the fuel line, get pulled in through the carburetor, and start to run out. I'll turn on the hydrogen from the main valve The hydrogen flow is controlled by this pressure valve here, and I will start to put in the hydrogen once I hear the change in the RPM. That means the carburetor is running out of gas. Still running on gas. We're running at 1200 RPM at 647. Now the RPM has changed. I'm going to give it a little bit of hydrogen. Give it some more air. We're running at 1500 RPM. We're running at 1500 RPM at 690 degrees Fahrenheit. It's running stable. More air. More hydrogen. 1500 RPM. 2000 RPM. Hydrogen. RPM. More air. More air. $3,500 RPM. 37. 4,000 RPM at 925 degrees and holding 934, 937, 938, 940. And we shut down the hydrogen. So we ran it up to 4,000 RPM on the tach, and it showed 942 degrees Fahrenheit on hydrogen compared to the 1,000 degrees plus on the gasoline. So you see there's a 60 degree difference in temperature lower on the hydrogen. In a previous test that I did on the temperatures, I showed a 140 degree difference between hydrogen and gasoline, hydrogen being the lower temperature at 140 degrees, but the difference was I ran it during the day as opposed to running it now in the evening, so the temperature of the gasoline EGT is even lower than it was on the previous test that I ran yesterday. Well, that is all for this test, and there is another video coming soon where I will be doing a combustion analysis of the engine running on both gasoline and hydrogen to show the differences in the actual emissions coming out of the tailpipe. Until then, have a great day. Look forward to the next video.